For an organization like NetApp, where we have a pretty large code base like ONTAP, we are going to have developers who are working with gigabytes of data and hundreds of thousands of files on a day-to-day basis. So a typical P4 sync or a Git clone to create a workspace for ONTAP is going to take somewhere around 30 to 35 minutes for a developer. And that seems like a pretty critical bottleneck impacting developers' productivity. So we have developed an internal solution called Build at Scale, which works very well for ONTAP and tremendously reduces this 30 minutes of workspace creation time to merely 30 seconds. So this session is just going to give you a brief of what Build at Scale solution is and what are the components of it and how we developed it for ONTAP and how we are leveraging it for other organizations. So Build at Scale basically has its infrastructure laid upon key techniques leveraged from ONTAP and Kubernetes. So this is a modernized approach, rebuilding our solution for ONTAP, and now it is extendable and applicable to pretty much all organizations with a concerning workspace creation time. So the components of this solution are, the first thing is we have a SCM instance where our source code is going to reside. And then we have a Jenkins instance for a CI/CD pipeline, and then maintaining and building our CI/CD and builds. And we have a mechanism to tag the successful builds. And we also have a success criteria defined to mark each build as a good build or a bad build. The key point of this solution is that instead of doing a P4 sync or a Git clone, the developer just has to select what is called as a checkpoint from the solution in order to create a workspace. So by means of selecting this checkpoint, one is that the workspace creation time is reduced from like 30 minutes to 30 seconds for ONTAP, and then the build time is also reduced from 30 minutes to like 8 minutes for a full build versus an incremental build, since this workspace is a pre-built workspace. And we are also exposing an UI which is developed from Python Flask, and it is hosted as a web service by itself, and it is hosted upon Kubernetes cluster. So this UI is going to tie together the different components and exposes a set of functionalities to the developer and the DevOps admin. So they both can use the Build at Scale UI to create and manage the workspaces and also create and manage the pipelines. And under the cover, we are leveraging ONTAP snapshots, which are very versatile in terms of space and time efficiency, to create the checkpoints out of good builds. And similarly, we are also leveraging ONTAP flex clones to roll out read-write resources and produce it as a workspace to the developers from the ONTAP snapshots. And like I mentioned, we are using Kubernetes to host all the different instances like SCM instance, Jenkins instance, and the Build at Scale UI as different Kubernetes services. And beneath the services, they are using ONTAP volumes for storage. And we have developed the Build at Scale UI using Python Flask application, and that by itself is hosted as a web service using Kubernetes. And we are also leveraging some of Kubernetes APIs, ONTAP APIs, and Jenkins APIs to automate most of the tasks through this process. So this is the workflow of, high-level workflow of how this Build at Scale solution works. So we have Git as a source code management tool, and that runs as an instance hosted by Kubernetes as a service. And we have Git integrated with the Jenkins CI/CD pipeline. And the Git can talk to Jenkins instance in the sense that whenever there is a new commit or a new change pushed to Git, it can trigger a build or a pipeline in the Jenkins CI/CD. And the pipeline has the mechanism where it knows the build steps to do a build, and also the success criteria for marking a build as a good build or a bad build. So once the build is checkpointed using ONTAP snapshots, the user can access the list of checkpoints from the Build at Scale UI application, and then he selects one of the checkpoints and then creates the workspace. The actual workspace creation is facilitated through ONTAP flex clones, which is going to roll out a read-write resource from an ONTAP snapshot in just a few seconds. So this is how for ONTAP, the 30 minutes of workspace creation time has been reduced to just 30 seconds. And this 30 seconds actually includes the time required for passing on some metadata to the SCM. So the flex clone is actually going to consume even lesser than 30 seconds. So once the developer has a ready-made workspace for further development and testing, they can add their changes, do the tests, build, or whatever they want to, and then they push the changes to the Git SCM, and then the process repeats. Here is a two-minute demo depicting all the workflows, which we saw in the previous slide. So the first step is an admin persona. This is the build at scale application, which is listing all the services, like the SCM instance running as a Kubernetes service. And we have an artifactory, which is optional, used for storing the build artifacts and images for the other services. That is also running as a Kubernetes service. We have Jenkins as a Kubernetes service, and we have ONTAP also running as a service. And we have CouchDB, which is used by the application itself for storing internal metadata. So the admin is creating a Git project and pushing in some of the source code. And using this project URL, the admin is going to create a pipeline using the build at scale UI. So during pipeline creation, we provide the URL of our project and then also specify which branch the project corresponds to. And then we go ahead and create a pipeline. Once the pipeline is created, there are some bare minimum integration which is already in place for the Jenkins pipeline job. So using this, the admin can add more steps to customize the build and also define what a successful build is. And initially, the first build on the Jenkins has to be manual to make sure all the pieces are working together fine. And once this build is done, this build is going to create a checkpoint which can be accessed by the user from the build at scale application. So now the user goes to the create workspace page from the application and selects a pipeline and provides username, and now selects a checkpoint which was created from the first build. And this creates a workspace which can be accessed either via command line or using a browser-based IDE like Thea. So we are using Thea for the purpose of this demo, and Thea already has Git integrated as part of it. So the developer can directly make a change and then produce a commit, and then push it to the master branch from the IDE. And the IDE also provides a terminal or a shell where the developer can run tests or builds or other standard Git commands. So once the workspace is created, pretty much the rest of the workflow is going to be using standard Git commands like git commit and pull requests through Git, and then using git push to push the changes to the branch, and then merge to merge it to the master. So the only thing which differs in the solution is that we will be using checkpoints which the solution creates using ONTAP snapshots instead of doing a P4 sync or Git clone. And further in the session, we'll also be showing how we are deploying the solution using Kubernetes and ONTAP, and how we are leveraging Helm charts to make the solution easy to deploy. And other than that, we'll also be going over into more details on other key ONTAP techniques which we have leveraged to implement the solution. Thank you.